Hi everyone and welcome back. This is Module 3 for the AZ-305 certification. And as you see on this slide, it's a relatively small part of the percentage, only 10 to 15%. So take it with however much effort you want to put into it. If you know this really well or don't, you can kind of gauge how much, but again, it's a very small percentage. The other three modules are almost 90% of the exam, but you still got to know some stuff here. So let's go on in here and see what we've got to talk about. Let's start with design, backup, and disaster recovery solution. So the Azure Backup service provides simple, secure, and cost-effective solutions to back up your data and recover it from the Microsoft Azure cloud. You can back up files, folders, system state using the Microsoft Azure Recovery Services Agent, also known as MARS. Or you can use the DPM or Azure Backup Server agent to protect on-premises virtual machines, either in Hyper-V or VMware, and other on-premises workloads. You can back up the entire Windows, Linux VMs using backup extensions, or backup files, folders, and system state using the MARS agent. And you can back up, ready for this list, managed disks, Azure file shares, SQL Server databases running on Azure VMs, SAP HANA databases, Azure PostgreSQL SQL databases, and operational backups for Azure blobs. Did you get all that? There's a lot of benefits mentioned on this link, but some callouts to note would be backing up on premises to the cloud, backup Azure IaaS VMs to a recovery vault with short-term and long-term data retention. You only pay for what you use. That is, it's a pay-as-you-use model. And finally, Azure Backup offers three types of replication models: LRS, GRS, and ZRS. If you aren't already familiar with those three letter acronyms, please do review the link, what you can back up. We also talked a little bit and had a screenshot in the last module 2 you can go back and review. Site recovery replicates workloads running on physical VMs and virtual machines from a primary site to a secondary location. When an outage occurs at your primary site, you fail over to secondary location and access apps from there. After the primary location is running again, you can fail back to it. I added a FAQ link as I think those types of articles are always good finds when preparing for exam, just chock full of odd tips and tricks. So please make sure to review that one. Again, it's on my blog, which I've been showing throughout the video series. The third link for Azure Site Recovery shows the most common architectures for multi-tier application in Azure. This picture is the very last scenario in the link to configure VMs in an availability set into separate availability zones when you enable replication for your virtual machine by using Azure Site Recovery. The SLA will be 99.99% after you complete the move operation. Understand Azure Backup architectures, it's important to know the components and processes that make it up. We covered many of these aspects at the beginning of the slide. Like many things in preparing for the exams, it's easy to set up and configure in a portal. Then you can really see what all the possible settings are to configure. Backup policies is one of those examples, as depending on the requirements you're given for a scenario, they may dictate how to configure a policy. A couple of callouts on backup policies are these things. 1. Any changes made to the retention period of a backup policy will be applied retroactively to all the older recovery points aside from the new ones. And 2. When you can have daily backups, note this retention for a monthly or yearly backup points is referred to as long-term retention. Another video pause point is this chart that compares the different types of backups. I would think that knowing and understanding these options may be helpful in determining exam answers that you may have to choose. On this link for Azure Backup Server, it has a long list of supported options for applications backup, VM backup, and Linux. Seeing that this entire BCDR section is only 10 to 15% of the exam, I wouldn't spend too much brain power in trying to learn all of that that's on the link. On pages like this, I try to look for the outliers or things that you may not think about. For example, Azure Stack HCI is supported. Do you need to know what Azure Stack HCI is and does? Surely not. But to protect it, MABS is the option. Or another note that caught my eye on that page is on Azure ExpressRoute support. You can back up your data over Azure ExpressRoute with public peering available for old circuits and Microsoft peering. But backup over private peering isn't supported. The final thing that caught my attention on this link is that there is a cluster support for file servers, SQL Server, Hyper-V, and Exchange Server, but Azure Backup Server doesn't support backing up on SQL Server databases hosted on cluster shared volumes. But this doesn't mean that it doesn't support SQL Server. It can back up a stand-up SQL Server instance or a SQL Server failed cluster instance, or FCI. Azure Backup provides independent and isolated Azure Virtual Machine backups. Backups are stored in a recovery services vault with built-in management of recovery points. Configuration and scaling are simple. Backups are optimized, and you can easily restore as needed. Backup is available for Windows and Linux VMs. An Azure Backup job consists of two phases. First, a virtual machine snapshot is taken. And then second, the virtual machine snapshot is transferred to the Azure Recovery Services Vault. A recovery point is considered created only after both steps are completed. The recovery point is used to perform the restore. You can define the backup frequency and retention duration for your backups. Currently, the VM backups can be triggered daily or weekly and can be stored for multiple years. In Phase 1, snapshots are stored locally for a maximum period of 5 days. This is referred to as the snapshot tier. In Phase 2, snapshots are transferred to the vault for additional security and longer retention. This is referred to as vault tier. Some things to consider in planning the backup of Azure VMs. Consider grouping VMs that require the same schedule, start time, frequency, and retention settings within a single policy. Implement both short-term, daily, and long-term weekly backups. Make sure to review and change your backup policies. Enable monitoring and alerting features, and then actually review the results. And then finally, consider cross-region restore, which allows restoring Azure VMs in a secondary region, which is an Azure paired region. Cross-region restore is an opt-in feature for any recovery services vault. Cross-region restore also works for SQL databases and SAP HANA databases hosted on Azure VMs. All right, it's time for that eye chart again. So you might want to pause the video to review this one. Both SQL databases and SQL managed instances use SQL Server technology to create full backups every week, differential backups every 12 to 24 hours, and transaction log backups every 5 to 10 minutes. The frequency of transaction log backups is based on the compute size and the amount of database activity. When you restore a database, the service determines which full, differential, and transaction log backups need to be restored. Azure SQL Database automatic backups remain available to restore for up to 35 days. But what if you need it longer? Then use the long-term retention feature, or LTR. This way, you can store the Azure SQL Database backups in read-access geo-redundant storage, or RAGRS blobs, for up to 10 years. If you need access to any backup in LTR, you can restore it as a new database by either using the Azure Portal or Azure PowerShell. Soft delete protects an individual blob, snapshot, container, or version from accidental deletes or overwrites. Soft delete maintains the deleted data in the system for a specified retention period. During the retention period, you can restore a soft deleted object to its state at the time it was deleted. A container soft delete can restore a container and its content at the time of deletion. The retention period for deleted containers is between 1 and 365 days. The default retention period is 7 days. Note, Container Soft Delete doesn't protect against the deletion of a storage account, but only against the deletion of containers in that account. To protect a storage account from deletion, configure a resource lock on the storage account resource. Blob Soft Delete can restore a blob, snapshot, or version that has been deleted. Blob Soft Delete is useful for restoring specific files. The retention period for deleted blobs is also between 1 and 365 days. Blob versioning works to automatically maintain previous versions of a blob. When blob versioning is enabled, you can restore an earlier version of a blob. Versioning lets you recover your data that's incorrectly modified or deleted. Blob versioning is useful if you have multiple authors editing files and need to maintain or restore their individual changes. Like Soft Delete, point-in-time restore for block blobs also protects against accidental deletion or corruption. For this feature, you need to create a management policy for the storage account and specify a retention period. During the retention period, you can restore block blobs from the present state to a state at a previous time. Azure Files provides the capability to share snapshots of file shares. Share snapshots give you an extra level of security and help reduce the risk of data corruption or accidental deletion. You can also use them as general backup for disaster recovery. It is recommended that you use Azure Backup to automate and manage file share snapshots. Before we move on, again, you may want to pause the video to review these steps. Geographies define a discrete market that preserves data residency and compliance boundaries. Geographies allow customers with specific data residency and compliance needs to keep their data and applications close. Geographies are fault tolerant to withstand complete region failure through their connection to our dedicated high-capacity network infrastructure. An Azure region features data centers deployed within a latency-defined perimeter. They're connected through a dedicated regional low-latency network. This design ensures that Azure services within any region offer the best possible performance and security. With the connectivity of the global Azure network, each of the Azure data centers provides high availability, low latency, scalability, and the latest advancements in the cloud infrastructure. Azure availability zones are physically separate locations within each region that are tolerant to local failures. Failures can range from software and hardware failures to events such as earthquakes, floods, and fires. Tolerance to failures is achieved because of redundancy and logical isolation of Azure resources. To ensure resiliency, a minimum of 3 separate availability zones are present in all availability zone-enabled regions. Virtual machine scale sets with flexible orchestration allows you to combine the scalability of virtual machine scale sets in uniform orchestration mode with the regional availability guarantees of availability sets. Azure Virtual Machine Scale Sets let you create and manage a group of load-balanced VMs. The number of VM instances can automatically increase or decrease in response to demand or a defined schedule. Scale sets provide the following key benefits. They're easy to create and manage multiple VMs. They provide high availability and application resiliency by distributing VMs across availability zones or fault domains. It allows your application to automatically scale the resources as demands change. And you can work at large scale. Scale sets support up to 1,000 VM instances for standard marketplace images and custom images through the Azure Compute Gallery, formerly known as the Shared Image Gallery. If you create a scale set using a managed image, the limit is 600 virtual machine instances. Most of the topics around high availability we've covered in previous modules. One topic that we didn't drill into much is high availability with Cosmos DB. Cosmos DB is designed to provide multiple features and configuration options to achieve high availability for all solutions availability needs. Cosmos DB is a fully managed multi-tenant service that manages all details of individual compute nodes transparently. Users do not have to worry about any kind of patching and planned maintenance. Using redundancy with no user involvement, Cosmos DB guarantees SLAs for availability and P99 latency through all automatic maintenance operations performed by the system. Replica outages refer to the outages of individual nodes in a Cosmos database cluster deployed in an Azure region. Cosmos DB automatically mitigates replica outages by guaranteeing at least 2 replicas of your data at all times in each Azure region where you create your account. This results in an RTO of 0 and an RPO of 0 for individual node outages with no application changes or configurations required. In many Azure regions, it is possible to distribute your Cosmos database cluster across availability zones, which results in increased SLAs, as availability zones are physically separate and provide distinct power sources, network, and cooling. For durability and to protect against complete data loss that may result in a catastrophic disasters in a region, Azure Cosmos Database provides 2 different backup nodes, continuous backups and periodic backups. The goal of high availability architecture in the Azure SQL database and SQL managed instance is to guarantee that your database is up and running 99.99% of the time without worrying about the impact of maintenance, operations, and outages. There are 2 high availability architecture models. Standard availability model that is based on separation of compute and storage. It relies on high availability and reliability of the remote storage tier. This architecture targets budget-oriented businesses applications that can tolerate some performance degradation during maintenance activities. Then there's premium availability model that is based on a cluster of database engine processes. It relies on the fact that there's always a quorum of available database engine nodes. This link covers the following service tiers: basic, standard, general purpose, premium, hyperscale, and accelerated database recovery or ADR. I put a picture of the hyperscale service tier as that's a little more complex. Note, the hyperscale service tier architecture is described in distributed functions architecture and is only currently available for SQL database, not SQL managed instance. You want to brief over the other tiers on this link, but again, keep in mind that this section of the exam is the lowest percentage area, only 10 to 15%. So you'll have to weigh how much time you want to spend here. So since ADR or accelerated database recovery is a pretty new thing, I would want to know a little bit about it. ADR is a new database engine feature that greatly improves database availability, especially in the presence of long-running transactions. ADR is currently available for Azure SQL Database, Azure SQL Managed Instance, and Azure Synapse Analytics. There you have it, folks. This is a wrap for Module 3, Business Continuity and Disaster Recovery. See you on the next video.